We are starting on page 2 in the blue guided practice packet. And this is where we start to put together what we did on Friday and what we were just doing. So we see a polynomial out in the wild. Ah, a polynomial. And we approach it as saying, can I factor it? What is the very first thing we always check for when we're factoring? GCF. Always, always, always. Is there something I can take out of all 4 of these terms? 6 is pretty close, but I can't take 6 out of -5. 5 is close. Nope, can't take it out of those 2. Can I take an x out? No, that constant doesn't have anything to give up. So there is no GCF here. Wah, wah. There are 4 terms, though. So what is that making you guys think? Split in half. Do the grouping. So we're just going to off to the side, because this is kind of what we want our brains to be thinking, is 4 terms grouping. That's our identifier. So we split it in half. Bunk. What's the GCF we can take out of the first 2? 6x squared. And that will leave us with 6x plus 1. Now, what are we going to take out of the next group? So, a -5. And why a -5? So then we'll get the same parentheses match for our unit. So 6x plus 1. So we got a match. Now, what would happen if we didn't get a match? If these ended up not being the same, if there was no way for these to be the same, then it's actually prime. If it's got 4 terms and grouping doesn't work, we're done with that. So luckily, it does work. We take out the GCF of 6x plus 1. And that leaves us with 6x squared minus 5. Can we factor that a little bit further?
Yeah. No, because they're prime.
Yep, they're prime at the end of grouping. And if you're like, but this is a quadratic, Mrs. Cairo. Yeah, but since there's only 2 terms, and it's not difference of squares, and it's not difference of cubes, we're done. Huzzah. And now we move on to number 16. GCF or not?
Yes. 27 times 2.
So there's nothing we can take out, which makes us sad because these are kind of giant numbers. But what type of giant numbers are these?
Prime.
Close. They are cubes. Now, 64 is unique because it's also a perfect square. But these are both perfect cubes. The x is cubed, the y is cubed, the 64 is a cube, and 27 is a cube. So what is our a then? This is what Mr. Beal taught you guys on Friday. 4x. Woof. What a, huh? Cube root of 64 is 4. 4 times 4 is 16, times another 4 is 64. What about 27y cubed? What's our b? 3y. So now, little parenthesis, big parenthesis. What's our happy little acronym for the signs? So, same. Same as the sun between the cubes. Opposite. Opposite of what you just wrote. Always positive. Always positive. So who remembers what goes in the first parenthesis? The a and b. So we got 4x. We got 3y. Ooh, this is the tricky part. If a squared goes here, are we going to write 4x squared or 16x squared? 16x squared, because I square both the coefficient and the variable. What goes in the last slot? B squared, which is 9y squared. What goes in the middle? AB. So multiplying those together would give me 12 X, Y. And it's kind of like grouping where it's like once you factor it, you're done. You're never going to be able to factor that any further. That's just a rule. That's just how it goes with sum and difference of cubes. So with that in mind, I want you to try 17 and 18. Yep, there's more factoring.
If you just be 13. Katie, how did you do it? 17. Oh yeah, question 17. How did Katie do it?
This is like a trick question. What do you do with the 13?
No way.
Yeah, what do we do with that 13, folks? Is that a perfect square?
No. 13 is right.
Is there a GCF? So we can't factor it. So it is prime.
Dude, I hate those.
Sorry.
Spend like 2 minutes like trying to figure it out and then it's front.
Blame prime.
You're trying.
18 is factorable.
Literally. I have no clue. Shut up, dude.
What do you do?
Check for a GCF. Do we have one?
No.
No. It is a quadratic. Anything jumping out at you about 9 and 49?
They're perfect.
They are both perfect squares. So this is difference of squares. We do the perfect square factors of 9, x squared, 3x, and 3x. Perfect square factors of 49, 7 and 7. How about the signs?
1's minus 1's plus.
1's minus 1's plus, 1's plus, 1 is minus. Order doesn't matter with those because multiplication is commutative. So let's go ahead and try a couple more. Actually, no, let's not. Folks, I think I'm going to give you the rest of the class time to work on the homework. Reminder that page 4 is due tonight. Pages 5 and 6, I don't have being due until Thursday. However, our test is Friday, and you will also have the review assignment due that night. So in your purple packet, I would be working on all the way through 53. And
I deadlift 225 and then I row 225
And then
and then I hang 225. Yeah. And then throw.
and after I show if I play back squat. And then I just
just those problems for right now.
that's all.